Example 4 says, a camping equipment company finds that the revenue gained from its most popular tent can be modeled by the function r of x equals 250x times e to the power of 1 minus 0.01x, where r of x is the revenue in thousands of dollars from the sale of x thousand tents. Find the marginal revenue when 75,000 tents are sold and explain what it means. So first we want to find the derivative of the revenue function. So we get that r prime of x is equal to the marginal revenue function, which is first times the derivative of the second plus the second times the derivative of the first. And so if we clean that up a little bit, we can factor out a 250, and we can also factor out e times 1 e to the power of 1 minus 0.01x. And that's going to leave us with 1 minus 0.01x. All right, so we have our marginal revenue function, and we want to find the marginal revenue when 75,000 tents are sold. Be careful because the input is in thousands of tents. So 75,000 tents means that x is equal to 75. So we want to find the marginal revenue by inputting 75 into our marginal revenue function. And if you throw that into your calculator, this is approximately 80.25. Now, what does that number mean? So this means that the sale of 1,000 more tents will give us about 80.25, and remember this is in thousands as well, in additional revenue. So all of the previous examples that we've looked at had us taking the derivative of an exponential function where the base was e, but what if we want our base to be some number a that's not equal to e? So if y is equal to a to the u power, where a is some number that is not equal to 1 and also greater than 0, and u is a differentiable function of x, then dy dx is equal to a to the u times du dx times the natural log of a. And notice that this formula still works for base e. It's just that the natural log of e is equal to 1, so this whole term here would just be 1, and you would just be left with this thing here if our base was e. So example 5 says find the derivatives below. Find dy dx if y is equal to pi to the power of x. So in that case, we will just use the formula from above. So we would have pi to the x power times the derivative of the power, which is 1, times the natural log of our base, which is pi. And that's we can rewrite as pi to the x power times the natural log of x. So that is the derivative there. And part B says find y prime if y equals 4 to the power of x squared plus 2. So y primed is going to equal 4 to the power of x squared plus 2 times the derivative of the exponent, which is 2x, times the natural log of the base, which is that. And so if I clean that up a little bit, that's going to be 2x times the natural log of 4 times 4x squared plus 2 as the exponent, and that is our final answer there.